Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
So the first thing we'll need to do is to actually fetch the location, to fetch the location, and we know, assuming let's say this was our jam. So I'll write that program here. Let me just write a simple that program. Let me write it in memory. So our jam is for 001. So I'll just write 01. So you see how the room works. So this is like 00001. And this is what is here. So it's 1 and this is hex. So hex is 1 in hex is 01. So there's a hex input. So I've written 01 here, which is a jump. And let's assume that I wanted to jump to location 5. So let me just say jump. And then that location now becomes what 01. So where do I want to jump? The location is an 8-bit location, right? So I want to jump to 0, 1, 2, 3, 4, 5. I want to jump to this location, right? That's where I want to jump. I could jump anywhere. It just an picture. So let me just say I want to jump to 10. It doesn't matter. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, let me say I want to jump to A. I want to jump to A. Remember, this is hex. This is in hex, right? This is hex. So this is jump to our location 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So maybe the audio sound, the audio quality. So we have to kind of we have to increment the program counter so that it can point to the next location, right? So that we can be able to fetch this operand, right, and then send it to send this operand, the location I want to jump to, back into the program counter. So let's do the first step, right? So we'll have to increment the program counter. So we will set the count enable, right? Program counter count enable. We'll set the signal high. The count enable signal. So let's look for it here. The count enable. At this step, that's what we will do. Count enable. Let me look for where the count enable is. Program counter PC count enable right here. So we'll set the signal high, right? So once you have set it high, once you have set this particular signal high, right, the program counter has not yet increment. It has not yet increment. So keep note of that. So we have to wait for the clock, because this signal actually waits for the clock. Okay, so we have to wait for the clock for it to be able to count to the next. And because our next operation relies on the result of the current operation, that is it. We have to wait for the clock in this case. So basically, that's all we will do at this particular step. So we wait for the clock so that it can be incremented. Then on the falling edge of the clock, we get to go to the next step, the next state, right? We will go to the next state, which is let me paste this one down again. So what we are doing here, let me comment it and see what we're doing to incrementing program counter. PC. That's all we did at this state. Let me have another state which is important. So at this state, we're at 111. This is the current step. So 011, yeah, 011. This is the step that we are at now. And at this particular step, we know that the program counter has been incremented. It's now pointing to the next. It's now pointing to the next location, to the next index. It's now pointing to where the operand is. So all we have to do is that we will output it to the data bus and then store it into the instruction memory address register. So we'll set the output enable high and then set the input enable of this register high, and at the rising edge of the clock, that will be executed. So you see how we are setting up our instructions and they getting executed at the rising edge. So let's set those signals high quickly. So that is the program counter output enable. We'll set it high and then set the instruction memory address register input enable. So let me come back to it. Where is the program counter output enable? So this is the PCOE here. It's here, so we'll set it high, and then set the instruction memory address input enable. This is here, so let's set it high, right? So we get to set this one high, right? So let's set it high now. So with this out of the, so once we have done setting it high, as you can see, we can't, there's nothing much we can do now. We have to wait for the clock again because we have set it high. It's on a data bus, right? But this is enable, so we have to wait for the clocks before this can be read into what the instruction memory address register. So as a result, we'll wait for the clock. So on the rising edge, it has been done, and on the falling edge, what will happen is that we will go automatically to the next state or to the next step, right? So on the falling edge, we'll know that so we'll go to the next step, which will be at step so what were we doing here? Let me also add a comment to it so that it become easier to follow later. So at this, what we're doing here was that let me this. So okay, here we're simply load content of program counter, right, into instruction memory address register, right? So let me still follow these things. This is what we're doing at this particular step, and then so since we are done with it, we'll go to the next states, right, which will be 0 1 1. So from 0 1 1, that will be 1 0 0. So the next step will be at 1 0 0. So we have 0 0 0 0 1 0 1 0 0 1 1 1 0 0. So we'll come at this particular step. So we are at this step, right? So we are at this step. We are at this step. We are at this step 1 0 0. So at this particular step, it seems we are already done. Like okay, so at this step, we at this particular step 1 0 0, we know that the content of the program counter have been loaded into what? We know that the operon, right? The location I want to jump to. Okay, let me see. Let me come back to that, right? Let me come back to it. Let me come back to that. So okay, let's see what has happened. So we loaded the content of the program counter into the instruction memory address register at this step, right? So once that is there, okay. So yeah, so the next step we have to output it. We have to actually output it to the data bus or to the line, right? So let's output 1 2. So let's output it, right? So let me come back. So what we have done now is that we have been able to load the program the content of this here. So which means once it's here, we are now pointing to where the operon is, right? So since we are pointing to where the operon is, we just have to set this one high so that it can be in the data bus. Then we'll copy it to the program counter. That is all that is left. So let's quickly set it. So let's set this to signal high. IMOE high, then PCOE high. So let's come to IMOE. Where is that signal? So this is a signal here. So this is the signal right here. IMOE. So this is a signal right here. So we'll set it high. And then we'll also set the instruction memory address register high too. So we'll set this signal here high, and then we'll also set the program counter input enable, right? Program counter input enable. Where is it? Okay, it's actually called program counter load enable. So we'll set PCLE high. Let's look for PCLE. This is PCLE. So we'll set the signal high. That's what we will do, right? So and yeah, so that is it. Basically, that is all. That is it. So let's try and see actually what we have done. But we'll go through when we're executing the instructions, so you'll get to know more of what is happening. So let's see. Let's see. Let's see what we can do here. So you have these things set right. Let me try and then you can get some things. So okay, so at this particular step, we have set this signal high program counter load enable. Then we also outputted the instruction memory address, output enable. So we outputted it. So what was here, we put it to the data bus, and then we set the load enable of this signal high, right? So that we can be able to load whatsoever in the data bus into the program counter, right? So once we are done, at the rising edge of the clock, that'll be done, and then we will not, and then the micro instruction counter will increment to the next step, right? To the next step. So let's go to the next step. So let me add a comment: load content of load instruction memory, or send an instruction memory. That is a instruction memory outputs to the data bus, something like that. Okay, that's what a signal was handling here. So it's you get it either you follow. So here, this is what we have done, and the commenting, just don't get, that's the comment. Don't get confused by them. We're just filling our table now. So we have done with this particular state, right? So let's see the next thing that we would like to do. Let's see the next thing that we would like to do, right? So once we are done, then at this instant, the micro instruction counter would have incremented to this state, right? So 101. So once this particular micro instruction counter increment to this 101, so we can be assured that we will be assured that that whatever that was, we have been able to successfully load read forwards here and then send it towards the program counter. So that's what we have done, and it's once we are done with that, because that's the only purpose of this instruction. So once we have been able to load the instruction, right, the location into the program counter, right, the location I want to jump to, once we have been able to load into the program counter, then we are done with the instruction. There's nothing else to do. We have already accomplished our task. Once you have been loaded into the program counter, it's done. So so at this state, all that we would like to do is that we want to reset. We want to clear the micro instruction counter, right? Because if we don't clear it, then it will just keep on counting and we are not doing anything. We're already done with the instruction. So we don't have to allow it to count all the other steps that we are not using. So that's why we are clearing it.